Hi, in this video we will learn about an interesting modifier called Displace. This modifier creates a magnetic field. This magnetic field comes from the Gizmo of this modifier. We can control the strength. We can play with the size of it. Also, this Gizmo here, for example, it's a circle, it's a cylindrical Gizmo. And here we have a spherical Gizmo. And in addition to that, we can map a texture on this Gizmo, like here. Texture like this one. This is like a height map for a terrain, and we can drive the force of this magnetic field from the brightness of this texture map. Also, we can use a procedural map. These maps, they ship with 3D Studio Max, and they are created using an algorithm, not a picture. Here we have multiple procedural maps we can use. So we will see each case separately. In the beginning, we will see how we can use it without any texture map or a procedural map, just by using the different types of Gizmo. So let's start from scratch. Okay, first I will create a plane. Now this plane has a 4x4 subdivision. Since this modifier will push the vertices, so I need a fairly large amount of vertices to make this to make the effect interesting. So I will increase the subdivision to 40x40. Now I will apply the Displace modifier. Now here, the Gizmo, I will pull it up so you can see it. I will increase the strength. As you can see, the whole plane is pulled up because the Gizmo has the same size as the plane, but I can use the scale to make it smaller. Now, from this Gizmo, from each point of this Gizmo, there is a force pulling perpendicular to this plane. And now by default, they are pulling up. So if I rotate this, you can see now we are pushing downward. Now, if I move this up, let's make it parallel. Now, you notice that if I move it up and down, the strength is not affected by the distance. And this is because the decay is 0. Now, when I increase the decay, the more I increase the decay, the more the impact of the distance increases. Now, if I move it up, now you can see that the strength of this magnetic force is decreasing. If I make it closer, I will put it 0 again. Now I will try another shape for the gizmo. I will make it spherical. Now I will put the sphere on the 0 here. I will increase the strength. As you can see, the plane is still planar. The reason is that when it's spherical, the top part of the sphere, the forces are from each point of this sphere. There is a force going, pushing in a perpendicular manner relative to the place on the sphere that this force is going out. So the upper part, we have these forces pulling in this direction. Here they are pulling in this direction, and on the peripheral part they are pushing in a horizontal manner. So basically the plane is only affected by these on the peripherals. But if I move this up, you can see that we have this. Now if I move it down, you'll see this. Now let's make it a cylindrical. I will rotate it 90 degrees. Now with the cylindrical, the force are coming from this side. This part here, the cap, and here, there is no force coming out from them, only from this part here. So when I rotate the cylinder, if I scale it, you can have some interesting effects. Also, if you like, you can animate this gizmo. I will keep it cylindrical. I will turn on the auto key. I can press the N button shortcut. I will move the time slider to 20. And move the gizmo here. I will move the time slider to 45. Now I will turn off the auto key, bring back the slider here, and press play. I can add a turbo smooth to make it even more smoother. Of course, you can also animate the scale and the rotation. So basically, I will stop this video here, and in the next video, the part 2, we will talk how we can control the strength of this magnetic field using a bitmap or a procedural texture. Thank you for watching. If you like this video, please press the like button and subscribe to the channel, and see you in the next tutorial. Thank you.